How's everybody doing? Good. All right. So I'll put up a warm up in just a minute. It's actually from the slides we didn't use yesterday. So if you already went through the slides, you might be a little bored for a minute, but I think you'll be okay. And I did just notice that the slides that I had posted were old slides. I don't know what was happening because they didn't even match, but so I've changed them a little bit. So in case you previewed them and they look different, they are different. So, but not dramatic. I mean, kind of dramatically, but all the information is there. So try this first. Find the sample spaces of the following. So I'll give you an example of the first one. So a single die is rolled. So the possible outcomes are 1, 2, 3, 4, 5, and 6. So that's how you did the first one. So I want set notation, and you can write out the sample space. All right. So for those of you just getting here, we're just working on this warm up for a minute, and then I'll do a We Share Wednesday. And then I'll also put in the chat the handout that we're going to work on today. And again, you don't have to make a copy of it unless you want to. You can just write on paper. All right. So welcome. It's Wednesday. Can you believe it? We have a lot going on. This feels like the longest week in the history of the world after last week. So, and I just sent you guys an email a while ago about office hours tonight. Did you guys get it? I don't know if you did, but I have midterms. I actually have to give 9 oral midterms today. And my first one starts at 1:20. So we will be definitely out of class by 1:20. Yes. So I know, I love that face, Vanessa. You're like, oh my. And yes, so I will be available for office hours at 6 p.m. from 6 to 6:50 if you need me. I will be there. Otherwise, next week should be regular, and I always have my morning office hours that nobody comes to, except for Sunita stopped by this morning, right? So we'll do We Share Wednesday in a minute. I just wanted to make sure you knew that. And if you can't come between 6 and 6:50, you were planning on coming between 7:30 and 8:30, maybe you can shoot me a message on what I can help you with, and we can figure it out that way. Or, I mean, especially if you can't make it between 6 and 6:50. So that being said, I'm just going to put up the answers to these first ones, and then we'll do our We Share Wednesday. So you might have written it a little bit differently, but so 2 coins are tossed. There's 4 possible outcomes. Did you write down all 4? Some people forget to write down one of them. They think that TH and HT are the same, but they're not, right? Because one is coin 1 and one is coin 2. So, I mean, you could have written heads and tails, but that's what I wrote. HH meant heads, heads. HT, heads, tails. TH, tails, heads. And TT, tails, tails. Everybody okay with that one? Okay. 2 dice are rolled. This was kind of a pain because you had to write them all out, but there were 36 possible outcomes, right? You could have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and then you could go all the way. So there's 36 possible outcomes when you roll 2 dice. And then the genders from the birth of 3 children. There's 8 outcomes. Hopefully you didn't forget one. And then if you toss 3 coins, there's also 8 outcomes, which, by the way, that should make sense, right? That tossing coins and gender outcomes, if you're doing 3 births or 3 coins, they would have the same number of outcomes. Yeah. So any questions on those? So sample space just lists all the possible outcomes for the event. Karina, does that help? So, and we could have, like, an event could be just one of those outcomes, right? So, but the sample space, we list all of them. Everybody okay with that? Any questions on that? So sample space is an important thing to know when computing probabilities, because then I can ask you lots of questions about these things. Like if I say, what's the probability that you get 2 heads if you toss 2 coins? So what would the probability be if you toss 2 coins? What's the probability that both coins are heads? 1/4. That's what Amanda put in the chat. You are right, because there's 1 outcome that's heads, heads out of the 4 total outcomes. That's why knowing the sample space is important, right? How many outcomes are in the sample space? All right. The next thing I want to do is I just want to do our We Share Wednesday. So you guys can share anything you like, something good happening, something bad happening, whatever. And then I want to share one that normally I would share on Thunderbird Thursday, but it happens tomorrow. So that's why I want to share it today. Anyone want to share anything that's been going on?
I can share. Yesterday was pretty weird and hectic and scary. We actually, there was someone in the neighborhood who was jumping into people's backyards who wasn't in a good state of mind. So that was pretty scary because we had to check like our backyard and stuff. So, and then, yeah, he was found down the street in someone else's backyard. So that was scary. But yeah, it's what I had to share.
Vanessa, that sounds terrifying.
Nerve
And
wracking.
you know what's crazy is that same thing happened in my neighborhood like 2 years ago. And I remember it was 2 years ago because we were out of town dropping my son off at college. And I don't normally leave my kids home alone, even though they're pretty old, you know, so they were like 17 and 16 at the time. And we were literally gone for like 2 days. And, you know, they knew neighbors to call or whatever. And I was getting ready to walk into a library tour in California for the campus where we were. And um, our Ring doorbell went off. And it was a policeman at our Ring doorbell saying that somebody was jumping in the yard. And then my daughter called me on her cell phone. She had just left the house and the guy was right by our wall and he was like running away. So, and he again was also not in the right state of mind. I think he was definitely on some substance. And it was, of course, I'm like, literally, I never leave my kids home and I'm gone out of town and this happens. So, and it was, she was very scared.
Yeah, because I was getting home and my neighbors were out, so the cops weren't here yet. And so they let me know, they were like, oh, like, is your dad home? Because he was just in our backyard, so he could have like hopped over to yours. And I'm like, oh my God, I was like, yes, he is home. And they're like, oh, you should check your guys' backyard. And I was like, oh God, it was like fun.
Yeah, I'm
I
not
was like,
checking the
okay.
backyard. Somebody else can check the
Yeah, I
backyard.
was
I'm
like,
just
Dad, I was like,
saying.
you need to go outside. I was like, you need to go check the backyard because I'm not doing it.
Yeah, but boy, it was funny because we had just put in the Ring doorbell not that long before. And so, like, the police officer gave us his cell phone number, and he's like, because my daughter had just left, and he's like, let your daughter have my cell phone number if she's coming home and she's scared, you know, we can come by the house and check it. That's crazy. So the Ring doorbell was very worth it right then. Anyone else have something to share?
So I was in preschool, I think it was maybe Monday, and they have those little counting cubes in there, and they're only 3 years old, so they can't do much with them, but I was showing them like magic tricks. I was just showing them like multiplication and division on those things, or what was it? I think I showed them 2 + 2, and they thought it was the coolest thing ever. So yeah.
Yeah, you're a rock star for that, right? That's why it's so fun to teach those little ones, right? Because they're so in awe of everything you do. Nice. I feel like I won the lottery. Did I tell you I got all 3 of my kids' vaccination appointments? Yeah, yeah. I'm a rock star right there. So 2 of them got vaccinated Sunday, and of course I couldn't get all 3 of them at the same time because that would have been way too much. But then my youngest, I take him tomorrow. So hooray us. Anyone else? All right, I'm going to share my screen different for a second because I want to show you what I needed to share with you today. So I don't know if you guys know meal kits, you know, like you can order Freshly or HelloFresh or anything like that. Well, tomorrow at our campus from 10 a.m. to 6 p.m., they're giving out meal kit food bags to MCC students, and it'll have a recipe and ingredients to make a meal for 4 people. And they were put together by students at Rhodes Junior High who were part of the College Bound program. So that's kind of cool. The other thing you need to do is you need to click to sign up to get the bag, and here it is. And they have here's the recipes. See, they have skillet pasta with chicken and broccoli, baked chicken and rice, vegetarian. They have 2 different vegetarian options, and tuna. So I just thought this was an amazing opportunity that I wanted to be sure to share with you guys. So, and I think it's cool that it's partnered with a school, you know, that's close to us. So does anyone know Rhodes Junior High? Yeah, it's right at Baseline and Longmore. So there's the Sign Up Genius. If you're interested in getting a meal pack, I definitely want to advertise it because I don't want them to go to waste, right? Even if you personally might not use it, maybe you have a neighbor who you know could use it. You know, pick it up, sign up and pick it up for them. So I had to share that today. Normally I'd share it tomorrow, but it is tomorrow, so I didn't want you to miss it. So we do Dinnerly. That's our food thing, and they deliver like once a week, and they deliver like 3 meals to us. And it's not, I wouldn't say it's super cheap, but it does include everything, and it's way cheaper than eating out. So if you like to cook, but you don't have time to shop, or you want to try it, because that's how we started. And my son uses it in college because he doesn't have a full meal plan and he has an apartment. And so he loves to cook. So he uses Dinnerly and loves it. And I think for him and his roommate, it's like $40 a week for 3 meals. That's a pretty decent price, right? So, because it includes all your vegetables and everything too. All right. So anything else? We Share Wednesday? All right. Well, feel free, if you think of something you really needed to share that you forgot to share, let us know. Okay, a couple things we didn't talk about yesterday. Equally likely probabilities. And equally likely means each event in the sample space has the same chance of occurring. A real easy one is coins, right? The probability of heads, the probability of tails. Another real easy one is, can anyone think of another real easy equally likely probability? Like a dice. Does that make sense, right? If you roll a dice, every number has the same likelihood. Not everything has an equally likely probability. For example, our weather, we definitely don't have equally likely probability, right? So the chance of rain isn't usually 50% chance it's going to rain, 50% chance it's not going to rain, right? In Arizona, if it gets to 30%, we're like having a party, right? 30% chance of rain, that is like amazing, right? What do you think our chance of rain today is? Yeah, I'm pretty sure it's 0. Yeah. So, yeah. But so equally likely probability is just a nice one to remember. Kids think everything has an equally likely probability, by the way, right? They don't really get it. So have you ever seen like a spinner and like maybe you have a spinner split into 4 sections, but 3 of them are the same color, right? Then that's not equally likely probability, right? Because one has a 1 in 4 chance, the other has a 3 in 4 chance. Bernoulli's theorem, we talked about this just a tiny bit yesterday. So Bernoulli's theorem is the law of large numbers. And so here's an example. So if we flip a coin 500 times, we're likely to get closer to half heads and half tails, even though it's not guaranteed that we will get 250 heads and 250 tails. So you can see the further and further out we go on this graph, we get closer and closer to that 0% over or under. This one we talked about a little bit yesterday. The sum of our probabilities should be 1. So if this is rolling a 1 on a dice, the probability would be 1/6. So the probability for not rolling a 1, or the complementary event, in other words, rolling a 2, 3, 4, 5, or 6, would be 5 out of 6. And if we sum those, we'll get 100% or 1 whole. All right, so let's try these. We're rolling a single die. We're assuming it's a fair die, right? Yeah, so it's just a regular dice that has 6 sides. So compute these various probabilities. That is divisible by 2, divisible by 3, greater than or equal to 5, prime, a 7, and less than 7. Okay, so try those. When you're done, type to me in the chat what should be for dessert today. What should be for dessert? All right, I think some of you are getting close. Am I right? I mean, I got a lot of your answers, but by the way, if I wasn't hungry before, I am definitely hungry now. Yeah, and Texas sheet cake, are you kidding me, Hannah? I haven't had that in so long.
It's so good. I think that we need to have a party and just have that.
Yes, yes. Well, or we could have all of these. We could have brownie, Nutella with apples. Yeah, how about just the Nutella? I can skip the apples. That's terrible. I do like apples, but I have to be in the mood. And I'm not sure that counts as dessert. That would be a snack for me, right? Dessert's got to be like pretty, I don't know. Okay. Tell me, is this what you got? Did you get 1/2 for divisible by 2? Yeah? Did you get 1/3 for divisible by 3? Do we remember what divisible means? Yeah, I picked those words because that's 256 vocabulary that we may have forgotten. So, and part C should be 1/3. Prime, now I gotta ask you this. Prime numbers, there's 3 of them. Nobody listed 1 as a prime number, right? Nobody thinks 1 is a prime number because it's not. Yeah, are you okay? And then it's a 7, that's the empty set, so the probability would be 0. And then less than 7, that's going to be everything. So those last 2, E would be an impossible event, and F would be a certain event, right? When we talk about our vocabulary from yesterday. So are there any ones that you got wrong? Did everybody get 100%? Or did you figure out where you made your mistake on one of them or 2 of them? Yeah. Okay. Any questions on those?
So I don't remember much about probability, but I thought we weren't supposed to reduce it because it wasn't as accurate or something. I remember hearing that somewhere.
Nope, it's fine. So in more, it will require you to simplify your fractions. We're not going to use that word reduce, right? Because it doesn't get smaller. It's the exact same location on the number line. I want you to flash back to 256 number line, right? And remember, they hold the exact same position. So you can simplify them. On more, you'll be required to. On my tests, I'll tell you if I want them simplified or not. Okay. So the one time in probability you have to be careful with simplifying is in ratios. So for example, if we were doing a ratio of 2 to 1 of boys to girls in a class, right? And we wrote that ratio like this, 2 to 1. If we simplify that to 2, then we've lost meaning, right? Because now it's not a ratio anymore. So that's the one time you have to be real careful with that. Good question, Karina. Any other questions? All right. How many of you know decks of cards? Be honest. Tell me, like, do you know a deck of cards? Like you're familiar with it. You play cards. Yeah, so Tyler does. Who else does? Sunita. I want you to look around. Madison does. Amanda does. Hannah does. Okay, Bethel's like, I think so. I'm not sure. I wanted to raise my hand. Okay, and when I mean a deck of cards, I mean a regular deck of cards. I'm not talking Uno or Go Fish or something, right? Okay, so, and some people say nobody plays cards anymore. Cards are outdated, right? Like, okay, that is the biggest problem I think about our problem solving skills is not playing cards. Cards is a great way to learn strategy as well as mathematics. And it's also one of the cheapest manipulatives you can buy for your classroom. You can use them as young as kindergarten, right? You can use them in preschool. Why? They're built-in manipulatives for you. So they have hands-on things already on them. Have you ever tried to teach a kid that, let me just zoom in right here, that this number right here, that looks like a 4. Have you ever tried to teach a kid that? Yeah, or how to make a 4? You are not making any sense to them, right? They can count. Kids can go 1, 2, 3, 4, 5, and they have no idea what they're talking about, right? They don't have any number sense at all. They're just counting. But in a card, do you notice that right here, there are 4 on there? Right? It's built in for you. So it's a great manipulative as young as kindergarten. Think about all the things we learned in 256. You can compare numbers, right? Take out all your face cards. Just use the numbers 2 through 10, right? And kids can compare which one's larger, which one's smaller. Does that sound like a game of war to you? If you've ever played war with cards? That's exactly what you're doing. You're comparing numbers. Now what you need to do is make them put in a greater than or less than sign to reinforce those symbols, right? So you can do ordering numbers. you can do sorting activities with really young kids, right? Is it black or is it red? Is it a heart or is it a diamond? Is it a club? Is it a spade? All of those things. But you can also do fractions. Did we talk about fraction war in 256? Okay, so do you know the card game war? Some of you said you don't know card games at all. But in the card game war, this is what you do. You each turn over a card and you decide whose card is bigger. Whoever card is bigger wins the war, right? So if I turn over a 10 and the other person turns over a 4, I win and I get both of the cards. And the object of the game is to get as many cards as you can, right? Till the other person runs out. So now picture this. Let me see if I can find my fraction war handout really quickly. It's okay, I can't get my hands on it, but I'll just draw it for you what it would look like. So fraction war, we'll just go down here to the end. Fraction war, I even had little like maps that looked like it. So, hello. And there were boxes here that fit the card perfectly. And they can be laminated for the students, right? And you guys can still see my screen, right? So let's say kids turn over a card. So they might put a 4 here, and then a 7 here, and this might be an 8 here, and this might be a 10 here. And then the students do just like war, but they compare these fractions, and they compare which is the larger fraction, which is larger, 4/7 or 8/10. And I hope you know that, by the way, right, from 256, that 8/10 is larger. So then the kid who put down 8/10 would get all 4 of the cards. The exact same game, but you can make it harder. You can let the kids choose which card goes where, right? So if a kid was with it and understood fractions, they would go like this, and then they would win, right? Tricky. So do you see what a high level game this is? You're like, I couldn't even play this, right? Like it's too much for me right now. I would have to think really hard. It's not a relaxing game, but it's a great in-class activity if you're practicing ordering and comparing fractions. So there's so much you can do with a deck of cards. So that's my sell on deck of cards. By the way, Bill Gates started a huge foundation. You're not as old as me, but my parents played bridge. Does anybody have parents or grandparents that played bridge? Okay, so bridge was very popular. And like my parents went to people's houses to play bridge like once a month. And bridge is a huge strategy game. And Bill Gates funded a huge Bring Back Bridge project, okay, and was having people learn how to play bridge. So it's fascinating. So if someone tells you you never need to learn a deck of cards, as a teacher, I'm telling you, one of the greatest things you can do is play cards with your class. They will learn so much. And if you're a parent, play cards with your kids. They will learn so much. You'll be teaching them mathematical skills that you didn't even realize. You don't have to play fraction war with them. Just play regular games with them, right? Regular card games. You're like, I don't know any. That's okay. Look them up. You can find them. If it wasn't COVID, we would have card game day. I promise you. But we did. Okay, so the reason I spent so much time on that is I want you to understand what a deck of cards looks like. And on a test, I will provide you with a deck of cards like this, a picture of a deck of cards, because that's not part of the problem, right? But it is a manipulative that's important. And it's in almost every probability textbook. It's in lots of things about probability with cards. Those of you that took 1-4X remember doing card problems, yeah? You know, you draw a king, what's the probability you draw a 9, all of those things. So just in case you don't know, here's some facts for you. A standard deck consists of 52 cards. So if you printed out that worksheet, or if you're using it electronically, you could chat these things up at the top, right? You could write them down up at the top. I probably have it in my notebooks if I could figure out where I put them. And my handout folded in half so I could put it in my notebook. And on the outside, I just wrote these things. I wrote that there's 52 cards in the deck. 26 are red, 26 are black. There's 4 suits. The suits are hearts, diamonds, clubs, and spades. And I put what color they were next to it. And then each suit has 13 cards. So if you looked across a row right here, there's 13 cards in each one of those rows, and they go from ace to king. Now, an ace, depending on the game you're playing, could be a high card or a low card, right? So usually when I do cards with students and I don't want them to worry about face cards and things like that, I just use 2 through 10 if we're playing an actual game, depending on what it is, okay? And then face cards, this is a confusing part. It's just these that are face cards, right? Some people think aces are face cards. Aces have no faces. Notice they don't, right? So only the jack, queen, and king are faces, okay? Everybody okay? Feel like they have a little bit about cards now? If you're not familiar with a deck of cards. So this might be very helpful to you to have an image of cards while you try to do some problems, okay? All right, so for warm up, let's try some of these problems. So you're getting 1 card. Or smoke or fire. Tyler, did you ever play smoke or fire? So Tyler just put, the game I will never forget is 52 card pickup. That's a fun one. And then Jessica said, I actually set up shapes as cards so they can see it by the number. What do you mean, Jessica? Tell me what you mean.
So like I actually just did this today in group time. So like I'll write the number 6 and then draw the 6, like say circles so they can count with me. Kind of like put 2 and 2 together.
Yeah, absolutely. That's a great strategy. And Bethel says 21. She plays 21. Did you ever play a game called 99? That's a fun game. 99 is a fun game. Gin Rummy, Hearts, Spades. I've played all of those. Yeah, 13. I don't know that I played 13. I have to think about it. Is it like 99?
Yes and no. It's going through 10 rounds, and each round you have 3, 4, 5, 6 cards, kind of like very similar.
I remember. Yeah. So Smoke or Fire is just a mean game, kind of like 52 card pickup with your kids. So you take a deck of cards. I did this in my classrooms every year, by the way. You take a deck of cards and you set them up so you have like 3 or 4, maybe even 5 black cards in a row. And then the next card is a red card. And you tell them, if I show you a black card, you say smoke. If I show you a red card, you say fire. You hold the deck like this. And so they go smoke, 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 smoke. And then they're getting irritated, right? Remember, I taught 8th grade. Don't forget I taught 8th grade. And then I go smoke, and then it's a red card. And they go fire. And you just literally like bend the cards and shoot them all over the room. That's the whole game. By the way, 52 card pickup is exactly like that, but without the anticipation of smoke or fire, right? So yeah, so super fun. Kids love it. They thought it was hilarious when I flicked those cards all over the room. Okay, so you're finding the probability of a queen, then you're finding the probability of a heart. These are separate things, right? And then it gets a little bit trickier. You're finding the probability of a queen or a heart, which if I was going to write it mathematically, what symbol would I use for or? What set theory symbol would I use for or? You're like, oh gosh, now we're back to the math. Keep talking about smoke or fire. We were better at that game. Okay, look. Remember set theory?
Is it like the N, the upside down U?
Okay, let's talk about it. So an and, which part of the Venn diagram do I color for an and? Anyone?
The middle piece?
Yeah, just this middle piece. So that's an and it has to be true for both of them. Yeah. So that's an intersection. So we use this symbol. What's an or mean in math? Which part would I shade in this picture?
The left and the right side circle, but not the middle.
Oh, not the middle? What do you
It
think?
would include the middle.
Why would it include the middle?
Because it's either queen and the heart, isn't it? Like it's all of them. Like you have to include the queen and the hearts, and you have to also include whether if you get them both.
Yeah, so interesting, because in our regular everyday language, if we say or, we use an exclusive or, right? We say it has to be one or the other. Like, right? Do you want a chocolate chip cookie or oatmeal raisin? Which if you pick oatmeal raisin, don't come to my house. I'm just saying. Just kidding. It's okay. Okay. So, but in mathematics, it can be both. So in mathematics, it could be both. So we shade the whole thing. And so an or is actually a union. So we would say queen or a heart. So that would be a union symbol there. Now this last one is, this is a very specific card. So this is the Queen of Hearts. Okay. I'm going to give you, some of you are already done with all 4 of these. Am I right? Because you were ignoring me for 90% of the time. Yeah, that's fine. How many of you are still working on some of them? Okay, so I'm going to give you about a minute to do it. If you already have them done and you want to just check your answers to me, that's totally fine. Just privately message me. Don't message everybody. Okay, or if you just want to wait, that's fine too. All right. Well, we're done. So no worries, Tyler. Okay. So let's talk about these. So the probability of a queen. So first, you might have to go back. If you don't know cards very well, you might have to go back and say, okay, how many queens are in the deck? And then how many total cards are in the deck? So you should have gotten 4 out of 52, which does simplify to 1/13. Now, I didn't say simplify, so either answer would be okay, 4 out of 52 or 1 out of 13. Any questions on that one? Okay, they get a little bit trickier. What's the probability of a heart?
Is it 13 out of 52?
Very nice. 13 out of 52, which would simplify to 1 out of 4. And if you're wondering where that 1 out of 4 comes from, you can see it right here, right? There's 1, 2, 3, 4. So it's 1 out of 4. It's kind of nice to look at it that way. We can simplify fractions with a manipulative as well. Nice. Okay. This one is a little bit harder. So I want you guys to talk me through it. What do you think is happening on this one? How do I do this? And you might think of some vocabulary words that we learned yesterday. What do you think we do if we have to find the probability of a queen or a heart?
Okay, I'm just gonna go for it. Wouldn't you just add 452 and 1352 to get 17 over 52? Because we have to have both the queen and a heart.
Okay, so here's our queens. Here's our hearts. But we might have a little bit of a problem. Yeah, Madison, what's the problem?
Well, if we added those two together, we're doing one card like the one in the middle, because there's one card that also has a queen of hearts, and we can't count that card twice in our standard deck. So we have to subtract one from our answer.
All right, so what type of events are these, or what type of events are they not? It begins with an M.
They're not mutually exclusive.
Yes, thank you, Hannah. So when you're doing this, don't eliminate vocabulary, because on your oral exam, when you explain things to me, if you just say, oh, I'm going to do 4 over 52 plus 13 over 52, and then I subtract 1, I'm going to say, why? And you're going to go, because I don't want to double count. And I'll say, perfect, why? And you'll say, well, because I counted it twice. And I'll say, but why? What probability vocabulary are you dealing with there? And you're like, I don't know. These are not mutually exclusive events, because the card can be a queen and a heart at the same time. So to eliminate that double counting, like Madison was saying, we have to subtract off one of those, because we counted it twice. If you look at your picture here, we would have counted it here when we had our queens, and we would have counted it here when we had our hearts. And so we have to subtract off that overlap, that double counting. So we would get 16 out of 52, which would simplify. What does that simplify to? 4 over 13. You notice that that number 13 is going to come up a bunch when you do probability with cards, right? Nice. Good job. Okay, how about this last one? I think this is the easiest one. The probability of the queen of hearts. One out of 52, because there's only one queen of hearts in the whole deck, right? So good job. Okay, there's our answers. And I put the little reminder in there of what you need to do. So now you have that card worksheet, and there's two sides. There's question 1 that has A through H, and then there's question 2 on the right-hand side. I don't think we'll get to question 2 till tomorrow, because those questions are a little bit different. When you're in your breakout room, what I want you to do is, let me see if I can pull this up. I've been putting, by the way, if you notice my notebook this time, I've created sub pages. I'm getting a little bit better with my OneNote. Okay, so I created a sub page, so the handout for that day is right underneath it. So here's my handout. Now, do you notice it says, write out the probability statement with proper notation, then find the probabilities of each of the following. So what I want you to do, sorry, apparently the recycle man's driving down my street. I have my window open because I love having my window open, and I'm going to have to close it anyway soon because it's going to be 5 million degrees soon. Okay, so the probability of a red card, well, that's going to be 26 out of 52, which is going to simplify to 1/2. And so that one was not too bad, but when you get further, sometimes you have to use, right, like set theory notation on or and not. What do we use for not for the complement? Do you remember what notation we use?
Was it a line over?
Yep, it's a line over the top. Okay, so I want you to do A through H, and H is a little troubling. So when you're in your breakout rooms, you can just work separately if you want, and then go over your answers together. But every person should be able to complete every problem. If you want to work through them together, that's fine too. Now, if you finish those and you want to try these other ones because you're more familiar with multi-stage experiments, you totally can, but don't feel pressured to. I'm more looking for, could you explain these problems and can you write proper notation? Okay, and make sense of them. Does everybody understand what they're supposed to do? Yes, Bethel, question, or were you saying I understand? Okay, good, just making sure. No, I'm gonna check it today. You don't have to turn it in. Okay. I have like 3 of you in each room, so. Okay, I'll come visit. Call me in for help if you need it. I don't know if you were waiting for me. We were almost done. Who was I just talking to? Bethel? No, Vanessa. Who? I couldn't.
Vanessa, but I was
Okay.
in the room too.
Okay. So I think, Vanessa, I'm not arguing with your number. So we're going to look at that one in just a minute. Okay. So let's do, let me look at your things. Let's do room 2, which is Michaela, Sunita, and Tyler. Which one do you want to do? I'll let you pick since I picked you first.
Well, can we do H because we're so confused on that one, but we kind
That's perfect. That's what I was hoping you would pick. Pick H. Go for it.
Okay, so we got 30 over 52 reduced down to 15 over 26.
Okay, I need a little bit more than that because I want some math going on here.
Yes, I can show you my little Venn diagram I did too here.
Okay, good.
I don't know if you see it. So I got the non-face cards and then the non-shaded cards and the little and in the middle. How I got the 30 in the middle is I looked at the deck of cards and I eliminated all my face cards and all my spade cards, and that left me with 3 rows of 10 cards. So I got 30, so I subtract 30 from both sides. So then we put 30 over 52 and reduced that down to 15 over 26.
You mean simplified, but yes.
Yeah, simplified.
Okay, so what I'm worried about your Venn diagram, Sunita, is if I add up those 3 circles, I should get 52. And when I add those up, what did I get?
19. Oh, 49.
Yeah, so something's wrong with your picture, right? Now, Alyssa's group, I remember, did this problem too. And Alyssa used your similar strategy where she was looking at this deck of cards because I was stalking them, watching them do this. And Alyssa, can you explain what you did?
Yeah, so I just I looked at them whole and I took away all the faces and I realized, okay, that's going to be the 12. And then I completely eliminated the bottom row because those are the spades. So then I just counted up 10, 20, 30. And then I
Yeah,
got
so
30 over 52.
yeah, so Alyssa did it with a picture. So she said 10, 20, 30 because I don't want face cards and I don't want clubs, right? And Sunita, that's what you were trying to do with your Venn diagram too, right?
Yeah, that's how I got my 30 in the middle. But I didn't, I think I forgot the spades and the face cards.
Okay.
So I have an extra 3 there, but the extra 3 should be in my, no, not in my, I don't think it should be in my middle.
Yeah, well, there's going to be, I mean, I did face cards. I did a Venn diagram too for mine, and I made one of my circles face cards and my other circle clubs. So in my Venn diagram, my overlap was just the king, queen, and jack of clubs, right? So that's how I did it. But so you know, your Venn diagram will be different. But I like your answer of 30 over 52 and 15 over 26. Can everybody confirm that that's what they got on that problem? Or some of you are like, we weren't even quite there, right? But what did you write for your probability notation? That's what I'm more interested in. Did anyone write anything for their probability notation there?
I did.
What'd you write, Tyler?
Well, I wasn't 100% positive because it's still an and I treated it like it was one of the other questions. So I put the probability of, and I don't know if there's a better way to write it, but I put probability of not face, and then I put the upside down U. I don't remember the actual name right now. It's skipping my main. And then not spade, kind of like, I don't know if you can see that or not, to try and justify it. That's what I'm looking for. But I wasn't sure if that was right or not, or if there's a better way to write that.
Okay, what do you guys think? Do you agree with the way Tyler wrote it? So an and is
Can you show-
usually an
Sorry.
intersecond. Yeah, show it again. Show it again.
Can you show it again?
He wrote not a face, intersection, not a spade. So what I did was, did you notice that on, which one is it? Did you notice that F says a face card or a club? And basically I didn't want that. I didn't want a face card and I didn't want a club. I mean, a spade, sorry. I was saying club. My gosh, did you guys just hear a crazy noise? No, yes, maybe.
An owl?
No, I don't know.
That was a mourning dove.
Yeah, I thought it was an owl too.
Maybe it was, I don't know. Okay, so the 30 over 52 and the 15 over 26, I like that. Yeah, I don't have any birds, so that's the terrifying part. Okay, face card. And a club. Oh, sorry, a spade. I keep saying a club, and there's a story behind that. And then I did it like this, a union with a line over it, because that's what I did not want. That's not the only way to write it. Set theory notation comes in many forms. So that's how I wrote it. So, and it's 120. So I have failed because we didn't get through this, and I have a midterm that starts right now. So I am so sorry. That's okay. We'll start this again tomorrow because we'll continue with the number 2 on there, and we'll finish this tomorrow. So sorry. Okay. Bye. Sorry. No exit ticket.